Hai guys, kita jumpa lagi. Lama tak tengok muka-muka. Esma, Nixon, Betty. Lama tak kacau kalian di kelas ya. So, hari ini kita sambung perbincangan kita. Kalau anda masih ingat lagi, handout ini yang saya pernah bagi dahulu. Okay, so kita sambung perbincangan 2.9 Analyzing Forces in Equilibrium. Okay, fill in the blank. So force are said to be in equilibrium when the object is either at rest, okay, is at rest, or if it is moving, so it must be moving at a constant velocity. Alright. So the net force that acts on an object when two or more forces act on it is also known as the resultant force. So this is the other name that we give to net force. Okay, resultant force. In Bahasa Melayu, this is called as daya paduan. Okay, when equilibrium is reached, the resultant force acting on the object is okay, so the resultant force, the net force is 0. Okay, so which Newton law that says that for every action there must be an opposite reaction with the same magnitude? Alright, so this refers to the third law. Okay, hukum Newton yang ketiga. Okay, a force can be resolved into components which are perpendicular to one another, which normally we use f of x and f of y, or f sub x or f sub y. Before we move on, I'd like to pinpoint this statement. The resultant force acting on the object is 0. Alright, so from F equals to MA, and we say that the resultant force is 0. Okay, so look at this mathematical statement. Okay, this mathematical statement. When will F become 0? Can M be 0? I don't think so. The only thing that can be 0 is A. So A is 0. The acceleration is 0. Therefore, our resultant force is 0. So if A is 0, then we have constant velocity. It also refers to an object is at rest. Alright. We can also resolve the components of a force into the x and the y axis. Suppose here is my F, and I want to resolve it into F sub x and F sub y. Okay, and we are given an angle of inclination here with respect to F sub x. Alright, so if I am to apply my trigonometry, sorry about that. Alright, so here is my right triangle. Okay, this one here is my right triangle. So if I use my sin theta, what is sin theta equals to? Sin theta equals to opposite divided by hypotenuse, correct? So that is my f sub y here, correct? Alright, so sin theta is f sub y divided by f. So I can write my f sub y equals to f sin theta. So if f sub y is f sin theta, then definitely f sub x must equals to f cos theta. So now we can answer this question. Okay, the horizontal force f sub x is equal to f cos theta, and f sub y equals to f sin theta. Okay, so bear in mind that this force can be resolved as f sub x and f sub y. Okay, the force is going up here, so I'm going to the right first and then I go up. So I start here, I end here. So I must move from here to the right and then I'm going up. That's how we resolve the force into the vertical and the horizontal components. Okay, let's move on. So in the table below, mark and label all the forces that act on the object. So here is my object. So I have a force going down. What is this force called? That is our weight, right? Remember that weight equal to mg. Okay, so if I have a force going down, I must have a force going up. And this force is what we call as the reaction force. Okay, this comes from the Newton's third law of motion. Okay, so R and W must be equal. Otherwise, either the object is going down or the object is moving up. But in this case, the object is sitting there stationary. So my W and my R must be the same. Okay, if an object is suspended by a rope, okay, so here is my object. So I must have a force going down. And what is this called? Yes, that is the weight. Okay, remember weight equals mg. The mass of the object we multiply by the gravitational acceleration, you will get weight. Okay, so at the same time I have a force from the object. This force must be going up. Okay, so this force is going up. So what is this force called? This is simply the tension. So remember that tension always comes out from the object. Normally in the classroom I don't draw this, right? Normally I will just use a free body diagram. So here is my object. So I have a force going down, that is my W. I have a force going up, that is my T. Okay, and the net force I'll write here F. So what is F equals to? F equals to T minus W. Alright, T is positive, my W is negative. It's going down, that's why I put here negative. Okay, we can also write this as T plus negative W. Okay, just for simplicity, I just simply write it as T minus W. And this resultant force is 0. How do I know this is 0? Because it says that the object is suspended. So the object is not moving. Alright, now let's go to number 3. You are now given a plane flying at a constant velocity. Remember just now we say anything that is moving at a constant velocity, we say that the object is experiencing forces in equilibrium, whereby the acceleration is 0, hence the resultant force is 0. Okay, so for this aeroplane, okay, so for that purpose I'm going to use my free body diagram. Okay, I have a force going down. What is this force called? Yes, this is our weight. And then I have a force going up. Okay, we normally call this R, right? So but for aeroplane we don't call this as R, the reaction. We call this as the lift. Okay, daya angkatan. And the airplane is moving to the right. Okay, so it's moving to the right. And what make it move to the right? Okay, so this is what we call as the thrust force. T-H-R-U-S-T. So at the same time, there must be a force going in the opposite direction. And this force is what we call as the drag. Seretan in bahasa Melayu. Alright, for this man here, okay, the cart here, it must have a weight going down, and then it must have also a force going up, and this force is what we call as the reaction force. And then the man is pushing the cart with constant velocity, okay, constant velocity. So I have this cart moving to the right. Okay, this is the pushing force. So at the same time, I must have a force going in the opposite direction, and this is what we call as the friction. Alright, daya geseran. Okay, so what is friction? It's simply a force that opposes the motion of an object. Alright, so we go to the next questions. So you are given the problem here. I have a box. Okay, the mass is 4 kilogram being pulled by a force of 60 Newton, and the angle here is 30 degree on the surface of a floor. So you are to calculate the component of the force which causes the box to move forward. So I have a force here. Okay, so I have a force starting from here, it ends here, right? So if I resolve the force, I have a force going to the right. Okay, so I will call this as F sub x because it is in the horizontal. And then I have a force from here, it goes up here. Okay, so here I'll call this as my F sub y. Remember that this is a right triangle. Okay, now, so the force applied is 60 Newton. So I will call this my F equal to 60 Newton. So the question asks us to find the force, okay, the force that is causing the box to move forward. So we have resolved this F into F sub x and F sub y. So which force is causing the box to move forward? Correct. So the force that is causing the box to move forward is our F sub x. So we are going to use our trigonometry. Okay, so F sub x is adjacent to my angle of 30 degree. So which one? Yes, we are going to use our cos theta. So cos theta equal to F sub x divided by the hypotenuse, that is F. Therefore, F sub x equals to F multiplied by cos theta. So next step, we simply plug in the value. Okay, so F just now is 60 Newton multiplied by the cos of 30 degree. Okay, so this shall give you 30 Newton. Am I right? No, sorry. You have to do the calculation. This shall give you 51.96 Newton. Okay, so that is the force that is causing the box to move forward. Alright, now let's go to the next question. Find the acceleration of the box if the frictional force between the floor and the box is 5 Newton. So I have a box here, alright, the box here. It is moving to the right with a force of 51.96 Newton, and then it has a friction which is opposing the motion of the box, alright, and the value of this frictional force is 5 Newton. Okay, 5 Newton, and I know that the box is moving to the right, so I write this as my F. But what is F equals to? F equals to MA. Okay, what mass does this refer to? It's the mass of the object. In this case, the mass of the object is 4 kilogram. Alright, so let's write the equation. Okay, so F, the net force for this system, right, equals, I have force to the right is 51.96, friction to the left, so there will be a minus, so minus 5. Okay, but then F equals to MA equals, so this shall give you 46.96 Newton. M in the question is 4, right? So 4A equals 46.96. Hence my acceleration, okay, that will be 46.96. We divide by 4. So you will end up with accelerations of 11.74 meter per second square. Okay, as simple as that. Now, let us move to the next question. So now what we have is a man, okay, pushes a box of mass 40 kilogram. Okay, so here is 40 kilogram up an inclined plane. The inclined plane makes an angle of 30 degree with the horizontal floor. Okay, so the angle here is 30 degree. The frictional force acting between the inclined plane and the box is 120 Newton. Alright, so I have a force, okay, going down, okay, in the opposite direction, and this force is 120 Newton. So we are pushing the box upward, okay, with the force of, okay, so the force here is 400 Newton. So that is the force, okay, and we are to find the acceleration of the box. Okay, so first we need to analyze the picture here. I have a mass of 40 kilogram. So if I have a mass, so definitely I must have a force going down, right? What force is this? That is our weight. So weight equal to mg. The mass of the box is 40 kilogram, and then g, normally we take it as 10. So here the weight of the box is 400 Newton. Okay, and at the same time I have a force going up, correct? But we are not going to write that force going up. It's useless actually. Okay, even though we can do that, but in this case I just want to know the acceleration. Okay, well, just draw the force. Okay, the force is going up, and this is our reaction force. Okay, calculate the acceleration of the box. So which direction does the box move? The box is moving along the plane. Alright, so let us draw another picture of that. Another picture. Normally in the class you will see me draw things like this. Okay, so I have a plane, and then here is a line perpendicular. Okay, so I will normally name this as my x-axis and this as my y-axis. Okay, now I will draw my force acting on the object. Okay, so I have a force going down, that is my W. A force going here, that is my frictional force, that is 120 Newton. My W just now is 400 Newton. Okay, and I have a force going to the going up the plane, and this is 400 Newton. Okay, so and the angle here is 30 degree. Yeah? So 120 Newton and 400 Newton is already on my horizontal plane, but my W is not, right? So this W, okay, this W I can resolve it into my X and my Y axis. Correct? So let us do that. So I'm going to use a different color for that. Maybe I use green. Okay, so I can resolve this. From here I'm going down and then I move to the left. Okay, so I'm going down and then I move to the left. So this is my W sub Y and here is my W sub X. I name this as X because it's in horizontal. Okay, parallel to my X axis. Okay, now what is the angle here? So just now the angle here is 30, right? 30 degree. So the angle here must also be 30 degree. Simple. Okay, how am I going to get my WX? WX is in opposite. It is opposite to my angle. So if opposite, I am going to use sin theta, correct? Okay, so I have my sin theta. Sin theta is sin 30 degree there, equals to my W, W sub X divided by my hypotenuse. My hypotenuse is 400. Okay, therefore my W sub X equals 400 multiplied by sin 30 degree. So that shall give you 200 Newton. Okay, do you follow? Okay, now let's finally solve the problem. So I'm going to use the available space that I have here. Alright. So I'm going to just simply use my free body diagram once again. I have an object here. Okay. And then I'm going, sorry. Oh, it's okay. I'm going to draw my X horizontal. I have a force going to the right. Okay. I have a force going to the left. Alright, now going to the right, I have 400 Newton. Going to the right, I have 120 Newton. I have another force going to the right, that is 200 Newton. My W sub X to the left, sorry. Okay, so I have another one that is 200 Newton. Okay, this is another force going to the left. Okay, now this box, I know it is moving in the directions of my 400 Newton because the man is pushing the box, right? So the box must be moving toward the 400 Newton. So this, I call this as F. So in this free body diagram, I am excluding my W sub Y. Okay, because my W sub Y will be cancelled off by my resultant force just now, my R. So R here must equal to W sub Y. Okay, so we are only interested in the forces acting parallel to my x-axis. Okay, do you get me? Okay, now let's solve the problem. So my resultant force here equals, okay, to the right I have 400 Newton. To the left, so it's a minus 120. Another one, minus 200. So what do I left with? So 400 minus 120 minus 200. So I only left with 80 Newton, correct? But this F equals ma. Okay, what is the mass of the object? Okay, the mass of the object given in the question is 40 kilogram. Okay, multiplied by A equals 80. So my acceleration is 80 divided by 40. So you will end up with 2 meter per second squared. So that is the acceleration of the box moving upward. Okay. Now, let us go to question number 7. So now I have a 4 kilogram trolley. It's connected to a load of 6 kilogram, and then the friction between the table and the trolley is 15 Newton. So I'm going to draw it here. Okay, but first I change the color of my pen. So the friction, it must be in this direction. That is 15 Newton. Okay, the load is then released, assuming that the pulley is smooth and the rope is of negligible mass. Alright, so if you are given this situation, I have 4 kilogram, 6 kilogram. So to which direction does this thing moving? So definitely it's moving toward the 6 kilogram. So I know this thing is moving down. Okay, and here it is moving to the right in the direction according to my heavier object. Okay, now find the resultant force that acts on the system. Okay, so I'm given the pulley problem here. So what I will do is I will just put it into my free body diagram. Okay, 6 kilogram. Okay, 6 kilogram is pulling it down. So here 6 kilogram is, I do have my weight of that object. 6 multiplied by 10, that will be 60 Newton. Okay, but the weight of this object is not acting, it's not doing anything, it's not in the direction of the motion. Okay, the motion is going to the right, but the weight is going down, right? Okay, so it has nothing to do with it. But this 15 Newton, it will try to hold this trolley up here from moving. Okay, so in my free body diagram, I am including the forces that is influencing the system. Okay, so here it is moving to the right. Okay, I put it as moving to the right. That is 60 Newton. And then I have a force which is holding it from moving. That is my 15 Newton. And I know that this object, okay, the system is moving in the 6 kilogram direction. It's moving to the right. Okay, so here is my resultant force. Okay, so what is my F equals to? So F, okay, equals here 60 Newton, correct, minus 15 Newton. Okay, so that will give you 45 Newton. But what is F equals to? F equals to MA. Okay, so we are answering question number A, 7A. Now, this mass refers to which one? We are talking about the entire system, correct? So, What is the mass? I have 4 kilogram. I have 6 kilogram. So what is the total of the mass? Okay, so my mass is 4 plus 6 multiplied by acceleration equals 45. So 4 plus 6 is 10, 8 equals to 45, and you solve for A, so my acceleration equals 4.5. Okay, so here is 4.5 meter per second squared. So that is my acceleration. Okay, so let's go back here. So the resultant force that act on the system, that will be 45 Newton just now. So I have to cancel this. Here is my A, here is my B. Okay, so the acceleration is 4.5 meter per second. Sorry for the math. So the resultant force F equals to 45 Newton. Acceleration A equals to 4.5 meter per second. Okay, now find the tension of the rope. Well, I have rope here, rope here. Okay, if this is the object, so the tension is always comes out from the object. So here is my tension. Here's the object, so I have tension going this way. Okay, since these two are interconnected, it is actually one rope. All right, so if this tension is T, then this tension must be T. They must be of equal magnitude. Okay, so to solve this problem, I am going to look into this object only, my 6 kilogram object. Okay, so I'm going to draw again. Okay, let's put here C. Okay, I have an object here. Okay, I have a force going down, that is my W. Okay, W equals to 6 kg multiplied by the gravitational acceleration, that is 60 Newton. I have a force going up, that is my tension. Okay, the tension of the rope. Now, to which direction is our resultant force? Okay, I know it's going down. So this is my resultant force. Okay, so how do we solve this? So my force F, okay, the direction is going down, so I'm going to put a negative F here because my F is going down. Okay, equals, okay, T is going up, okay, so it's a positive in front here, minus my double W. Okay, W is a minus, it's going down. Okay, now T is what we want to find out. W is 60 Newton. What about F? Okay, F equals MA, remember? So I simply write here as negative MA. What mass does this M refer to? Well, we are talking about this object. This object is 6 kilogram. So negative mass here is 6. What about the acceleration? Well, we have found out that the acceleration just now is 4.5 meter per second. So this load is moving down with a velocity, with an acceleration of 4.5. And this object here is moving to the right with exactly the same acceleration, that is 4.5 meter per second. Okay, so the acceleration here is 4.5 equals T minus 60. Okay, so I have T equals to 60 minus 6 multiplied by 4.5. Okay, so you plug this okay, into your calculator, you will find that my tension equals 27 Newton. Okay, so that's how we find the tension of the rope.